So guys, I have a question about number 35 from the homework, which is a really, really good question. It's a beautiful example of how we use this stuff we learned in section 4142, how we use it in the real world. Do you guys, anybody in here, how many of you are not quite 25 yet? Anybody? All right. Do you happen to know, those who aren't quite 25 yet, do you happen to know what happens on your 25th birthday somehow related to your car?
It's 26 now.
Is it 26?
26 now. Yeah.
Really?
Yeah.
Shit, I'm sorry. Oh, that's awesome though. Well, not really. It's awesome for an example. So what is it you're talking about? Are we talking about the same thing? Huh?
Car insurance?
Car insurance. So it used to be, apparently, that when you woke up on the day of your 25th birthday, you suddenly knew how to drive because your car insurance rates would go down. Apparently, so how do they figure out what your rate should be is the probability that they'll have to pay out money. So given that you're a certain age, the probability that you'll get in an accident goes up or down. Does everybody agree with me? It probably is a bit of a inverted parabola because it's probably high when we're young. My God, we're dumb. I was young too, so I mean, we're stupid. And then you get a little better, and then you get older, right? Yeah. Yes?
Did it go down to 25 because that's when, like, the frontal lobe is more fully developed?
No, not necessarily. It's just observation. They noticed that they paid out less money, and apparently, maybe they've been, so every company that has something like insurance company, any kind of business, they're gonna have somebody called a financial analyst. And they're gonna be one of the highest paid people that work at the company because it's their job to analyze every variable that affects the price they should set things at. And then they come up with the equation based on those variables and they predict what price they should set things at. That is a person that you want to know, them to really know their shit, because that's going to basically affect the efficiency. And by the way, I am not a business person. I hate business stuff, but that's cool because it's math stuff too. Eh? Yeah.
I don't know if it has anything to do with the insurance part, but when you're 25, you can also rent a car without somebody else signing off on it.
It's the same idea. Yeah, it's basically based on the same kind of data, which I'm curious now if they're going to change that too. So I got to investigate this. So I've been told that the age is now 26 when your insurance goes down, which would tell me that they've seen a change in the amount of money they have to pay out based on how old somebody is. Are you guys at all with me on this?
Yeah.
So there's a change in the probability that they'll have to pay out more or less money based on somebody's age. Therefore, they're going to set the rates on how old somebody is. So once you hit a certain age, all of a sudden, so I like to joke that you wake up and you suddenly know how to drive, but it's just probability of a big payout suddenly goes down. Are you guys kind of with me? Mm-hmm. Okay. Shoot, there was something else I was going to say and I totally forgot. Okay, well, that's too bad. So what does that have to do with this problem? You would actually set up a very similar table for number 35, you said, right?
36.
Okay. 35 and 36, same thing. Did I assign number 35?
Yeah.
And 36?
Mm-hmm.
Oh, look at me go. Okay, I love it. So if you can take the information they give you and you can put it into this. Then you can calculate an expected value. So an insurance company would put amounts of money they expect to have to pay out and the probability of each. So they could do that for people that are under 25, that are 18 to 20, that are whatever age groups. Are you guys kind of with me? Anybody also get a good student discount maybe? Do you guys know that you can get a good student discount on your insurance? Why is that? Because speaking probability, good students don't get into as many accidents. So they expect to have to pay out less, so they're going to charge that group less. Does that make sense?
Yeah.
Okay. Now again, does that mean a good student will never get into a big ass accident and it's completely their fault? No, of course that could happen. But just generally, it's not going to happen as much. Okay. So look at the data in either one, I don't care. Look at 35. What two outcomes are there? You can tell me, there's a few different ways you can answer that question. If you're going to play this game, what are the two main outcomes?
Face, non-face.
Yeah, or you could even say you win, you don't win, correct?
Uh-huh.
There's if you get a face card, you win. If it's not a face card, you lose, right? So, can you figure out what to put here then?
Oh.
Does it cost any money to play the game?
Oh.
No, right? They don't say it costs any money. Are you with me? So you just walk up and you're like, yeah, I'll play your game. You know, and so if I calculate an expected value and it comes out positive, if the expected value comes up positive, that means I expect over time to end up making more money than I lose. So almost every game in a casino, what do you think their expected value is for you?
You're gonna lose.
Negative, correct? That's why if somebody over there just won $2 million, the casino don't give a shit. In fact, they're really happy that happened because every other person there's losing. So that's a drop in the bucket compared to everybody else just pulled that thing and they just made $4 million and they just paid that guy $2 million. They don't care. You guys kind of understanding what I'm saying? Okay. All right. I like it. So let's try to set up number 35 because then you still have to do 36, I guess. Are they the same stupid thing? Yes, that's why I did it. Okay. This one's what's the expected value, and number 36 is should you play the game. So let me make a new game. Let's say you roll a die. And if you roll a 3, I'll pay you $10. Right? And if you roll anything else, you have to pay me $2. Is everybody with me on this? Right? And it costs nothing to play the game. You just come up and I'll give you a die and you roll it. Right? You can even bring your own die. Well, no, I don't know. We'll make sure somehow the die is not weighted. Right? So there's 2 outcomes, correct? So there's English, roll a 3, roll anything else, and then there's a mathish. How much do you make here? $10, right? So that's positive $10. But what about there? Minus 2. Everybody with me? So obviously if you're losing, the negative means it's flowing away from you. The positive means it's flowing towards you. What's the probability that you win $10?
1 out of 6.
1 out of 6, right? What's the probability you lose $2? 5 out of 6. Let me stop for a minute. Does everybody see that? And can you imagine how to do this then? I don't even care what the situation is. If you can count and figure out the probabilities associated with each outcome, you can set up a table.
How'd you get 1 out of 6?
Normal die.
Sorry, the 5 out of 6.
Normal die. Well, if 1 out of the 6 sides is a 3, how many are not a 3? The other 5. Yeah, cool. I like it. And these two have to add up to be 1. 6 out of 6, so 1, right? So how do I figure out what I would expect to make on average each time I play this game?
-2 times.
Yeah, you multiply across, you just get the expected value. So it would be 10/6. So the trick is when you have fractions, leave the denominators as the same thing, because you're going to have to add. You want like denominators, correct? So don't reduce any fractions at the end, just leave it all, so that it's easier to add at the end. Here you get negative 10/6, so what's the expected value?
0.
0. Do you see, we would call that a fair game. Because you're not expected to lose money, and I'm not expected to make money or lose money, right? Neither one of us makes or loses, so it's a fair game, which gamblers would call boring, right? You guys kind of with me? If I would have changed this to be you lose $3, what would have happened? Is everybody cool with that right there? Is everybody cool with that?
Yeah.
I'm going to change something. So let's say I say you lose $3. What would happen now? 15/6, right? Add these, you get negative 5/6, just below $1. Is that cool? I think it's about 83 cents or so, 84 cents. Yeah. So that means, now listen real quick. Is everybody cool with that? That's about 83 cents, right? You guys with me? So it's a loss of 83 cents. Is there any scenario where I pay 83 cents? What's the only 2 things that could happen? I make $10 or I pay $3, correct? Correct? So what the shit does that mean? That means that if I play this game a lot, and then I add up how much I won and I subtract how much I lost and average that, it'll come out to be 83 cents. You guys sort of with me? The fact that it's negative means the less of a gambler you are, the less you're going to want to do that. Because on average, I'm going to lose money, correct? The gambler's going to look at it and say, that's not that much. I can make some money. Why not? Are you guys sort of with me? We all intuitively have this. If it costs $1 to pay for a raffle ticket, and you might win $5, are you that invested in doing that? Not, right? No. What if it costs $1 to play a lottery, and you could win $1 million? Would you be a little more invested in maybe playing that game? Right? What if it costs $1 and you could win $1 billion? Now you're like, shit, yeah, man, give me a ticket. Why the hell not? Right? So we intuitively understand that even though the probability win-win is really low, when the payout is high, you multiply payout by really low, it still comes out decent. Are you guys with me? We kind of intuitively know this, yes?
What does the negative 83 mean? That's the probability?
83 cents. So again,
But it's negative 83 cents, right?
totally, that's why I had a negative. So negative, I'll do it like this. That's also 83 cents. Is everybody good with that? Everybody with me? Real quick side note.
Oh, just how much you lose.
Do you guys know the bowling alley that's at the bottom of the hill in Fletcher?
Yeah.
Forever, they've said 0.99 cents per game or something. Do you guys understand that's less than a penny? Do you guys understand that?
Yeah.
Do you guys understand that? That's 0.99 cents, which is not even a full penny. So I toss them a penny and say, keep the change, I'm gonna play your damn thing for an hour. So they should do that. Holy shit. Anyway, sorry. Little mini rant. Okay, sorry. So negative 83 cents. On average, I would lose 83 cents. Again,
Oh, okay.
I can't possibly, it's only get 10, lose 3, correct? But if I did this a lot and averaged my winnings and my losses, I would come out to negative 83 cents.
Oh.
Okay, maybe.
Mhm.
Okay. So you can do the exact same thing on 35 and 36. Yeah. Sure, yeah. A few people came in who did not get, well, let me just do it this way. Let's see. Oh my gosh. So tiny. Jordy? Lance is not here. Juan? Aziz? Donovan? Steven? Kayla? Lopez? Carla Mendez? Well, you're not in the homework part. So two things. Contents. So this either is from the practice or the homework. So this one was practice part. Number 30, whatever. Carla Mendez. Oh, sorry. Diana. Palomino. Lillian Perez. Maria Sabah. Sema. So quiet. Where are you? Oh. Oh, sorry. Sema. Okay. Anything else from homework or the quiz?
Professor,
Yeah.
would you say then, for example, then you would not recommend playing this game because you stand to lose 83 cents?
Again, it depends. It's not that much, right? So it really depends. It doesn't cost a damn thing to play, does it?
Or you can say 83 cents isn't too bad, you could stand to win $10.
Yeah,
Why
you
not?
know, to me, if I lose $3, that's not a lot, but it's still a decent little hit, right? I don't know. It really depends on the old adage about you have to have money to make money. That's a really good example, right? So if you play games long enough, you get to a point where you start getting some returns. But for example, when I go to a casino, which is very rarely, I go in with a set amount, and thank God I'm able to stop, so I don't have any of that psychology of gambling, right? But if you don't have enough money to play something for long enough, you're never gonna quite get that streak where you actually make some returns, right? So anyway.
Or you could say play it once and if all you lose is 83 cents.
Well, no. If you play it once, is it possible to lose 83
No,
cents?
you lose $3.
Yeah.
So if you play it once, you get $10 quit.
Yeah, basically.
Okay,
Yeah, it's just like,
cool.
a friend of mine and I, when we turned 18, we went and got some scratch-off tickets, because I don't think you're allowed, or at least in Virginia, weren't allowed to get them. We got $14. And we were like, holy shit. So we turned them all in and said, give us all new cards. And then every one of them was a loss. And we're like, well, thank God that happened. We're not gonna, I'm done with that. Anyway. All side notes, I'm sorry. Does that make sense as far as how that connects to those problems up there? Okay.
So, would you keep them as a fraction, or could you just turn it into a decimal? And so
If
it's the
you
same?
turn it to a decimal, you're gonna have to round. Do you understand? If you turn fractions to a decimal, you're gonna eventually have to round, in which case you're not gonna get quite the right answer. If I play this game 100 times, let me see who really gets this. If I play this game 100 times, how much money will I make or lose? Each time I play the game, I expect to lose how much? If I play it 100 times, how much do I expect to? $83 I'm gonna lose, right? On average. Could somebody win every time?
Sure.
Is it possible with a perfectly weighted die? Is it possible to win 10 times in a row? Hell yeah, is it likely? If I see somebody win 10 times in a row, I'm gonna be like, okay, empty your pockets, show me a thing, hold out this, give me the thing. I don't know what you're doing, but I gotta stop, right? If I'm the guy running the thing, I'm like, I'm not making money, it's not good. So, when I had -2 up here, that was not a good game for the person running the game, correct? Because they wouldn't expect to make money overall. Here, you can even look at it, not just you playing the game a lot, but what if 100 people came by? If 100 people came by and played the game and I'm running the game, I'm gonna make $83 on average, right? Sometimes a little less, sometimes a little more, but if I do this every day, I'm gonna average $83 for every 100 people that come by here with me. Do you understand? Do you guys understand? No. Everybody's sort of like, you're saying word stuff, but okay.
Is there a place where you would graph like X amount of times would equal this winning?
Oh, basically what I just said. If we know how much loss is happening each game, I just have to multiply by the number of games now.
Oh, okay.
Right, so if I play 5 times, I would just multiply that by 5.
Okay.
Yeah. Is that all right? So just like my little brother said once, what does 50% mean when you throw a coin? You're either gonna get a head or a tail, you're not gonna get half of something. It's because the 50% only makes sense in the long run. If I flip the coin 1,000 times, now 50% means something, I expect to get around 500 heads. Negative 83 cents doesn't make shit's worth of anything if I play the game once. That number is not gonna come up. You guys with me? I could either win 10 or lose 3. There's just no. It only makes sense if I do it a lot. Okay, maybe. Okay, enough of that one. All right. So that relates to 35 and 36 somehow.
Thank you.
So the answer to number 36 could be different based on your own. It's a little subjective about how much you would gamble. If the expected value was negative $250, I think most college students would agree with me that we're not going to play that damn game. Right? I expect each time I play, I'm going to lose $250. No, thank you. Right? If there was a chance to win $1 million and my expected value was negative 25 cents, I'm going to play that a few times. Holy shit, yeah. Right? You guys sort of understand? If I would have asked you that the first day, you guys would have all been like, sweet, and this is the math behind it. You get that?
Yeah.
Okay, I like it. And there are situations, I can't remember if I assigned a problem about the investments in here, I can't remember, but there are situations where it's not clear if it's gonna be a good investment. So investments is a big one for this. It's not clear, so if you run an expectation, if you run a probability distribution and look at the expected value, you can then make an informed decision. Yeah.
Could you take this and plug it into a formula to get a standard deviation?
Yeah, of course you get a standard deviation.
But you'd have to come up with a
X squared P of X, right?
Uh-huh.
Okay. Do you guys
But
want to
still need
do?
come up with n, right?
Huh?
You still need to come up with a.
No. Maybe it's a good idea. Do you guys want to do like a real quick full example? Find a mean, find a standard deviation for X P of X?
Yeah.
Or do you guys have any? Guys, most of you guys are like, let's just make it stop. Every day is with the statistics. exactly. Alright, so real quick. Let's see. Let's do. Alright. I'm about to ask you to do something for me. Can you check my math and make sure this is a valid probability distribution? You guys know what to check? Yes? What happens? Yeah, I'll probably set that at 1 and they all have to be between 0 and 1. Real quick. I don't remember if I showed you this, but do these add up to be 1? Yes. But obviously it's not a valid probability distribution because the probability of 0 is 150%. Do you guys see that? Okay, that's why you need both of them together. All right. How do I find the average?
Multiply and then sum.
So if you want to do it in your calculator, and again, you've got that handout, and if I were you and I'm doing chapter 4 homework, I'm gonna have the handout sitting right next to me. You got list 1, you got list 2, so you're gonna make list 3 be what?
X P I plus 1 times plus 3.
So it'll be list 1 times list 2.
Plus 2, yeah.
No worries. You don't want to be self-referential. Your Excel's gonna blow up. So then you multiply across. Oh shit, let's see. This is gonna be 1.65? No, 1 point.
No,
Is that right?
yeah,
Neato. I don't have a clue.
5.6.
5.6?
855.
Who is it?
8555.
855?
Yeah.
Okay, that makes sense. So if I add those up, what do I get? Not even a number. I mean, if I add those up, what will it mean? Let me say it like that.
16.7.
Okay. What is that? I always find this funny when I
Expected
do this.
value.
It's the expected value, which also means what?
The average.
Sure, the mean, right? Which is
Yeah, mean.
always funny to me when I say, what's this mean? The mean. So that's the mean. The mean is the sum of x, p of x. You guys with me?
Yeah.
And again, when they give the data to me, not in a list, but in a different format, I want to develop a shortcut to stay within that format. Do you want to write 9 10s, 11 15s, 35 16s, and 45 19s? Do you want to write that out? Add them all up? No, I'd rather have a freaking shortcut. That's what we did last time, was all that math showing you why this shortcut works, right?
Yeah.
Why is it, and again, I forgot to do this. What was the heaviest weighted thing? What's the heaviest weighted data point? 19.
19.
So doesn't it make sense that the mean is closer to 19?
Yeah.
Why is it lower than 19? Well, because 16 is pretty heavy weighted. These guys aren't heavy, but they're still something. They're gonna move it a little bit down. You guys see that? I like to think of it as weight. So it's gonna be closest to the heaviest weighted thing, but that's pretty heavy too, so it's gonna pull it back a little bit. Okay, maybe. So 16.7 makes sense. If you got 7, you should realize you are wrong for a couple reasons. 7's lower than every damn data point, right? And it's nowhere near the heaviest weighted thing. Okay, so that's the mean, also known as the expected value, which is funny because the first 3 letters look like EXP. How do I get the standard deviation? Let's see, what's the formula? Oh, let's do variance.
X squared P of X, 285.8.
Minus the mean squared, right?
Yeah.
So here's the thing I had a big discussion with my class earlier. Whenever you see a formula and it's got the summation symbol in it, whatever's next to it, you need to make a column of those. Because what is the sigma, what does that mean?
Summable.
So I need to sum these up, and I cannot sum these up until I actually make them, right?
Yeah.
So I need to make a bunch of x squared p of x's, so then I can add them up.
9, 24.75.
Well, look,
God, sorry.
what's up?
Nothing, just get side distracted.
Understood.
Think of that.
All right, guys. to make x squared p of x, to me, there's a few different ways to do it, but the way I do it is I do L1 times L3. Is that cool? Because x times x p of x is going to be x squared p of x, right? So if you're doing this in your calculator, you would make L4 equal to L1 times L3. And again, that's on your little handout that I gave you last time. So, good Lord, here we go. 9, you're going to have to help me out a lot. What's this here? It's roughly
24.75.
24.75?
Yeah.
And this guy,
89.6.
and this guy.
162.45.
Who to what?
162.45.
Alright. You guys with me? It's a relatively short list, so you don't have to do all the list stuff if you don't want to, but the longer that list gets, the more you're going to want the calculator to do all this stuff for you. And you could do the list, math, sum, to get the sum of the fourth list, right? So if I add all these up, what do I get?
285.8.
285.8? And what is that? That is the sum of what?
X squared p of x.
X squared p of x. So anywhere I see this, I can replace it with that number. When I see that right there, which of course is the reason we made it, right? So this will be, the variance will be 285.8 minus the mean squared. So double check that. 6.91. Okay. And then the standard deviation, of course, you just do what to those square root?
2.6287.
So make it 6.2.629.
Yeah.
That's not like really big standard deviation. Would you guys agree with me?
Yeah.
And one reason is 45% of the data, well actually 35% of the data is only 0.7 away from the mean. Do you guys see that? The mean is 16.7. 35% is 16. So 35% of my data is only 0.7 away from the mean. Another 45% is only 2.3 away from the mean. So when I average how far everything is, that makes sense. There's a few things that are further, but not that many. Okay, maybe. Maybe. Okay. All right. So that's what we did last time. So let's get into this last section of chapter 4. Let me just put this guy back up to this guy. There was a problem on the quiz that we're basically going to take and expand on. Maybe this over so you got more room. I can't remember on the quiz. It depends on what version you had, but it's basically the one where there were 4. I picked 4 people. One of the probability the first 3 did this or whatever, right? That problem? Okay. So. The probability that somebody is left-handed in the United States, as far as I know, is 11%, roughly. How many people in here, if you're willing to tell me, if you're left-handed? Anybody left-handed? 1, 2, 3, 3. Okay. And there's 2, 4, 6, 8, 10, 14, 12, 14, 16, 18, 20, 22, 24, 26, 28. 30, 32, 34, 35. 3 out of 35. What's 3 out of 35? It's about 8-something percent. Will anybody help?
8.57.
Who is it?
8.57.
8.57%. Okay. So a little bit lower than what we would expect. Okay. Which is fine, because any group could have more or less left-handed. It's just on average, every group should have about 11%. That's what I would expect to see. Are you guys all with me? Yeah. So the kind of problem we've already done, the kind of problem I could have put on this quiz would have been, if I pick 5 people, 5 Americans at random, what's the probability exactly one, I'm not sorry, that's the one we can't do. The first one is left-handed, the last 4, not. I'm not gonna say right-handed, because how can you not be left-handed? Is there only one way to not be left-handed?
No.
Yeah, exactly, thank you, that's the one I always go to eventually. Some people say ambidextrous, and then I say, what about people that don't have any hands? Then you wouldn't say they're any hand, but you would say they're not left-handed then, right?
Yeah.
Okay, there you go. So left-handed, not left-handed, that covers everybody. Okay, I love it. Can you guys do this?
Yeah.
Okay, how would you set that up?
111 times 28.
Yeah, so at 5 people, I want the first one to be left-handed and the next 4 to not be left-handed. So it'll be 0.11. Where'd that come from? Good, so probably left-handed is 0.11, probably not left-handed, 1 minus that. Kick ass, right? Because that covers everybody. You gotta be in one of those 2 groups. I like it. And then, of course, all these are 0.89. And again, just to do a little math, what would algebra say? We kind of laugh at this. What's a better way to write this? 4th power, right? Is that cool? What's the power on 0.11? 1, first power, correct?
Mm-hmm.
What does this mean? 1 lefty, 4 not lefties, yes?
Yeah.
It's a beautiful realization that the exponents are actually telling you a story about what the hell's going on. Real quick, what is that?
0.0775.
0775?
Yeah.
Is that right?
Oh no, times 4, forget about it.
I will.
0690.
Yeah, 0690, that sounds about right. Okay, so that's old news. That is old news. So here comes the new shit. Okay. I want you to realize we're going to enter the derivation zone right now. So we're going to be doing a lot of stuff right now that you're not going to have to do yourself. So agree with me. We're going to develop a formula that we're going to use that's going to shortcut a lot of what we're about to do. Unfortunately, you picked a teacher that likes to show you everything, where things come from. Okay, so if you don't like that, look away. Look away. Okay. So same idea, same stuff. How is this question different from the one we just did? The question is going to now be, what's the probability? So I still have probably somebody's left-handed is 0.11, probably somebody's not left-handed is 0.89. If I'm looking for left-handed people, let's say I'm out wandering and I need to find left-handed people. If I find a left-handed person, wouldn't you call that a success?
Yeah.
If I find somebody who's not left-handed, that would be a failure, right? All right, so let's do this. Let's give some slightly easier stuff to work with than P of L and P of N. I'm going to call the probability of success, I'm going to call it little p dude. And the probability of failure, I'm going to call it little q dude, right? So P is the probability of success, Q is the probability of failure. A success doesn't have to be a happy thing. If I'm looking for dead bodies, I find one that's a success. If I'm looking for rabid squirrels, I find one that's a success. You guys with me? Yeah. Success means what I'm looking for. It doesn't mean a happy thing, necessarily. Okay. So how is this question different from the one I just asked? I want to know the probability. So I still pick 5 people. Probability that I get exactly 1 left-handed person. And I'm telling you, it's not a trick. They are different questions. Why are they different questions?
Would that be the same as at least 1? No.
No, it's actually, that's something we're going to do later. This is exactly 1, right? So look. Let me see, what's the easiest? Here's 5 people right here. Everybody, right? There's 5 people right here. Those 3 and these 2. The problem we did was he's left-handed and the other 4 aren't. Is that the only way that out of those 5 people I get exactly one left-handed person? Is there another way to do it? Maybe the second person is left-handed. So watch this. 5 people, right? I could have the first person be left-handed, so I'm going to use a P, is that cool? And then the other 4 aren't. Or the second one is left-handed. You with me? Yeah. So I'm gonna let the that sounds terrible. I'm gonna let the P flow through. Or Q Q P Q Q, or Q Q Q P Q, or that Q is really getting freaky. Q Q Q Q P. Does everybody understand? Each one of those is a different physical reality. Is everybody cool with that? Given a set of 5 people, the first one is your left-handed, the next one is your left-handed, the next one is your left-handed, blah, 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 blah. So this situation right here is first person left-handed, and second one isn't, and third one isn't, correct? And of course, and means multiply. Or another situation, and of course, or means add. Each one of those looks like P to the first, Q to the fourth. Is that cool? Algebra would look at all this shit and go, what are you doing? It's PQ to the fourth, you crazy fool, right? But how many ways was there to do it? 5. And I would add each one of them up, correct? You guys see that? So isn't it more likely that that exactly one of any of these 5 people are left-handed versus the probability he's left-handed out of these 5 people? Doesn't that make sense? In fact, it's exactly 5 times more likely that exactly one of any of them versus just him out of these 5. Are you with me? I'm sorry, I keep pointing at you. Okay. So didn't we already calculate this? So now I just got to do 5 times, and then you get this cool thing. Only a math teacher would say that, but 0.345. I'm sorry. When you get something like that, a little thing goes up my brain. Ooh, 3, 4, 5. How you guys doing so far? Now, the reason you do not want to have to make this list is because this list could very quickly get stupid long. This list was pretty short, yes? Even if I just say exactly 2 left-handed people, start to try to figure out the list. Right? If I said 2 left-handed, maybe it's the first 2. Or maybe let this guy go through, right? Or maybe let them both go through. I mean, do you start to understand? Even that's getting kind of gross to try to keep it organized. Are you with me? But do you all agree with me that I could tell exactly what these exponents are going to be? If I want 1 success and 4 failures, I'm going to get P to the first, P to the fourth. Where does this number come from? Why was that number 5? Why exactly was that number 5?
Because you picked 5 people.
It's how long the list was, correct? It's how many chances there were to do that. 1 plus 1 plus 1 plus 1 plus 1 is 5. Okay, so if I had a list that was 800 long, I would put an 800 here. You guys with me? Yeah. Okay, so what do I do then? Well, thankfully, we all have access to a freaking expensive ass little machine whose main job it is to freaking count shit. Yes? So a calculator. So let's try a different problem real quick, and then I'll show you how to use a calculator. In fact, before you even write anything down, does anyone need to borrow a calculator? Let's do that real quick. Make sure they have good battery before you get too far away. No, that's fine. Yeah, that's funny. Okay. All right.
How do you do cube though?
To the. On the right-hand side, you see the little caret button? We'll do it up here in a minute. I'll do it up on the overhead.
Oh, okay, okay.
All right, guys, so let's build up slow to this. Let's say that we have 40 people. And let's change things up a bit. Let's say the probability that they like mint chocolate chip ice cream is 0.672. Okay. You guys with me? It's my favorite one, but you know it's not. It's very special.
What about mint cookies and cream?
Dude, close second. I got a lot of close seconds. So don't. All right. Probably somebody likes mint chocolate chip ice cream is 0.672. We pick 40 people, right? And I want to know the probability that exactly. What do you got, Jeff? Let's do 28 of them like mint chocolate chip ice cream. McKick. Mint chocolate chip ice cream, by the way. Right, I don't want to write all that crap out. You guys all with me? Okay. So let's focus on what we know. What is P?
28.
0.672.
0.672. So P and Q are probabilities. They must be between 0 and 1. You with me? So one mistake that a lot of people made on that one problem on the quiz was, it was like 72.1 and you used 72.1. No, 72.1% is 0.721. You always have to make it the actual number. Percentages are extra shit that humans made up. We just made it up just to make really small numbers make a little more sense to us. Okay, maybe. So what's Q then?
0.338.
0.328. 11. So how, anybody not see where that came from? You know, like, what the hell are you people doing? 1 minus this, yeah. So these two always have to add 1, so one of them is 1 minus the other. Kick ass. So, I mean, how many successes does this question want to have happen? 28, right? So aren't I going to have 28 successes? Is that cool? So how many failures am I going to have?
12.
There's 40 total people.
32.
Not 32.
What?
40 total people, 28,
12.
Oh, 12.
12, right? Okay. So we know that shit already. The thing we don't know is like the number 5, right? We don't know that. We don't know, and that would be how long the list is. Does anyone out there not quite understand? If you wanted to make the list for this, you would go insane way before you got done with it. Right? Some of you guys are like, got you beat. I'm already there. Okay. You would go more insane. Real quick. 40 people. Maybe it's the first 28 and the last 12 don't. Maybe it's the first 2 and the middle 7 and holy what? That's going to be stupid long. But does everybody understand what we're missing is a number that represents how long the list would be, correct?
40.
Huh?
40.
Nowhere near. Someone gets spooky. You're not even close. Okay. So, we're going to use the calculator to figure this out for us, because that's part of his job, is to just count shit. All right, so everybody get ready. I'm going to show you some cool shit. Boom, boom. Bless you. Yeah. Come on. Blazing speed. All right, guys. let me get us ready for this. Do you agree with me that when I made this list over here, I chose a place to put the 1p? So I had 5 spots, and I chose one of them to be the p, and then I moved on and chose another spot to be the p, right? So here, I got 40 spots, and I want to choose 28 of them to be successes, correct? Does everybody agree with that way of saying it? Okay. So watch the calculator. Let's see. So everybody type in here 40. Good job. Okay. Now hit math. We're finally going to use the math button. Probability. Now, which one of those do you think means choose? Yes, NCR, right? Let's see if anybody gets this. It's like a Fallout reference. Don't choose NPR, National Public Radio. Choose NCR. Real quick, do you guys ever heard of combinations and permutations?
Yeah.
All right, we're not going to get so deep into permutations. Combinations is what the C really means, but I always like to call it choose because that's pretty much exactly what that means, right? So what that does is if I feed it an N, a total number of things, 40, then I hit this button, number 3, and then I tell it how many out of those to choose at a time. So what was it, 28? 28. Everybody with me? Now, how many of you guys have it on the screen? It just says 40 NCR. Okay, then you just type in 28 at the end. You're actually better because the rest of us have to remember when we're going to put the whole formula in, we have to remember to hit the over arrow to get back up out of the subscript.
How do you do that?
You hit the over arrow. So you just hit the over arrow and then you're up there. But right now I just want to know what this number is. All right, does everybody just absorb that for a minute?
Okay.
If you try to make the complete list, what is that? That's 1,000. What am I looking at? That's 5,586,853,480. Do you understand? Do you understand? Do you understand? Okay. So that is not something that we intuitively understand at all. So when I was asking if you understand, I just want you to understand how big that freaking number is. There ain't no way you could just look at this. You're like, okay, that would take a little while, but you don't even know. There's no way the human brain could like immediately tell how many ways there is to choose 28 spots out of 40. I guarantee nobody thought it would be this, right? Nobody thought it would be this. But that's what it is. It's related to, did I tell you last time about the number of pizzas you can make if you have 13 toppings you can choose from? Is in the millions. It's basically the same idea as this, right? Because you have, you could choose so many toppings from a pizza, but then you could also do double of something or whatever, right? So there's a few more layers to it. Are you guys kind of with me? So 13 topping choices leads to millions of possible pizzas. Same kind of idea. This leads to billions. Okay. Everybody agrees with me that's a stupid big number,
Yes.
right? Okay. Now, remember, that's what's going to go here. So to represent it, I would put 40, choose 28. Isn't that what we just did? 40, choose 28. That means that number. Now, real quick, if I fill in the rest of this, this will be point, what was it?
72.
672. So what's the cube? Oh, we did over here. 328 to the what power?
12.
12? Everybody agree that this is really stupid small. In fact, can you just try to put this in your calculator by itself? 0.672 to the 28. Let's see if it's...
Yeah. 1.466
What does that mean?
to the negative 2.
Remember what that E means?
Yeah, you put it to the left 5 times.
Good, so it means times 10 to the... The shortcut is when you see the E, it goes back. If it's negative, it goes back 5 places. So if I go back once, I got 4 more to go, so 4 zeros. That's pretty damn small, right?
Yeah.
And then this is gonna be pretty damn small, so when I'm multiplying, it's gonna be stupid small. Stupid small times stupid big will average out to just fine. So what do I want to do? I want to plug all of this in at once. So we have to keep track. Look at this. I don't want to keep track of that shit. Let me put the whole damn thing at once so I can just spit out the nice balanced number. So let's try it. So let's do 40. Math, probability, 328. Hit the over arrow to come back up to normal. You don't want to stay down in the subscript because then it'd be 40 choose 28 times bullshit, right? You don't want to do that. Times 0.672 to the 28 times 0.328 to the, oh shit.
How do you come back down?
Oh, you hit the over arrow. It's crazy. Do you see how it's got a little image of an over arrow that it's blinking with?
To come back down?
Yep. To come back up, to come back down, you hit the over arrow.
Oh,
You with me?
yeah.
Yeah.
Would you use parentheses or just the little?
Either way. I don't need parentheses because order operation is not a
Will
problem.
that make the answer different though?
Nope. Let's see if we get the same answer. You guys all get that answer? Let me know if you didn't. Or forever hold your peace, I guess. Just trying to help. Okay. Everybody got that answer?
Yeah.
Oh, I kick so much ass. Okay. Technology day is always so exciting for me. So many errors can happen. Okay. So real quick, look at this. I really want you guys to understand. You can just read this shit. 40 people, choose 28 of them to be successes. So I got 28 successes, therefore I got the rest failures. It's a little paragraph of what the hell's going on. You guys sort of with it? Yeah.
And then what does the answer mean?
The probability of that happening. So what's the probability out of any group of 40 people, what's the probability exactly 28 are gonna like mint chocolate chip ice cream? 12.71% chance, right? You guys sort of with me? Now, if I only had, let's say I've got 28 bowls of mint chocolate chip ice cream, what probability would I actually want to know? The probability that, when am I going to be concerned? If I got 40 people coming and I only got 28 servings of mint chocolate chip ice cream, when am I going to be like feeling bummed out if more than 28 people show up? So I would actually want to calculate the probability more than 28. Now listen, how would I calculate the probability more than 28? Well, what's more than 28? 4, 4,
34.
okay, and up to 40, correct? So I have to do this formula for 29, 30, 31, 32, 33. Does that sound exciting? No. Good. So it is going to happen, but nowhere near that much. For example, if I ask, same problem, same stuff, same setup, but I'm going to ask a different question now. What's the probability that at least 2 like mint chocolate chip ice cream? See what you guys think. What's at least 2 mean? Some of you guys, hopefully, let's see. Some of you guys should go, all right, thanks, Jeff, you made it worse. Because what's at least 2 mean? 2 or 3 or 4 or 5 up to 40. Thank you. That's the way you said it, Jeff, I thought it was going to be better. What's the opposite of at least 2? Beautiful. Less than 2, which is? 0 or 1. So I'd much rather do 1 minus the probability of 0 or 1. Right? If the opposite situation has less work to do, I'm going to do that. Does that make sense? Maybe, no? I really want it to make sense. At least 2 is the opposite of 0 or 1. Does everybody agree with that?
Yes.
So if I figure that out and I do 1 minus that, I'm answering this question, right? This question had 38 or so formulas that I'd have to do. You with me? I have to do it for 2, I have to do it for 3, or for 5. The other situation has 2. Have to do the formula for 0 and have to do the formula for 1. You guys sort of with me? Okay. So you will see problems in the homework like this. I think the most you have to do is like 4 applications of the formula. You guys sort of with me? Be really careful. I might show you this, but not today. There's something called binomial CDF and binomial PDF. All right, if you get tutors that tell you about that, say, oh, dude, listen, I've got Jeff Waller. And they'll be like, I'm sorry, dude, okay. Let's set up the formula. I don't know what they're gonna say. They could very well say that. I don't give a shit. Because my point is, I'm here to teach you stuff. I'm not here to tell you what buttons to push so your little calculator could do stuff. I'm here to teach you shit. I will show you this eventually, just not today. I'll show you this because then you can check your work using this stuff. Not screw it, yeah. Yeah, I'm sorry, a few people.
What was the difference between you wrote P at least 0, at least 2, and then 1 minus P 0 or 1?
What's the difference? They're equal to each other. This is the opposite of this, correct? Anytime you have opposite probabilities, one is 1 minus the other one. Is that cool? Probably it's going to rain today is 5%. Probably it's not going to rain is 95%, right? 1 minus that, or 100% minus that, right? Any opposite probabilities do that. So again, I really want you to listen to this. Anytime they ask you a probability question and there's a lot of work involved, what's the opposite? If there's less work, shit, yeah, do that. Does that make sense? Right? Because then I can just do 1 minus that and I'm answering the question. No problem. Okay, maybe. Okay. Okay.
Wait, so how would you calculate 0 or 1?
Yeah, so if I wanted to do probability of 0, that would be 40. Choose nobody, yes? So now I'm just putting a 0 in instead of 28, right? Point, where was it, 672, yeah? To the 0, and then 0.328 to the 40. 0 successes, 40 failures. You guys with me? Okay, I like it. And that's why we call this number, whatever the number of successes is, we call it X, because it's the thing that's able to change. I get a 0 successes, or 1 success, or 2 successes. So just like in algebra, we call the thing that could change X.
Oh.
All right.
And then you add them up, and then 1 minus both of those.
Yeah, so you do the 0, and then you do the same thing. You put a 1 in, which will make that one what? 1, that'll be 39, correct? So you always make sure these two powers add up to be the total because you're taking the total, splitting them up into groups. So the powers always have to add to be the total number. Okay, I like it. Very often, there's a physical idea behind what an equation is trying to get me to do, which means there's a physical thing you can think of to make sure it makes sense. So if your powers add up to be a different number than the total number, you're doing something wrong because you've left people out or you've created people, which is neat. Okay, so let's do this.
Wouldn't it be just 1 minus the probability of 1?
What? What's the opposite of at least 2? I mean, how many people could like mint chocolate chip ice cream? If I have 40 people, how many people could like it?
40.
Or?
0.
That's an interesting way to do it. Or, so it could be 40 or 39 or 38, or 3 or 2 or 1, or none of them, right? Couldn't none of them like it? So what's the opposite of at least 2 liking it? 1 or none. That's the only 2 I leave out. So another way to think of opposite is, what does the original leave out? So what does at least 2 leave out? 0 and 1, that must be the opposite.
Okay.
Okay, I like it. Okay. All right, so, here, let's do this. So let's say P is 0.093, Q is, so what would Q be? I'm not going to tell you what Q is. I want to know probability, if we pick, you can do it, Jeff, pick 14 people, what's the probability that I get less than 2? So let's identify what we need. And one thing I have not done yet is to give you the formula for this. Have I even given you the formula yet, by the way? Have we done a lot of problems already? You guys, yes we have, haven't we? I mean, we've done a decent number of problems, so, I don't know, when I said a lot, I don't mean like 80 problems. We've done like 4 problems or something at least, right? And we haven't had the formula yet. Do you understand what I'm saying? I'm saying you don't need the formula. But here's the formula. N choose x, p to the x. Here's where things get weird. How did you figure out before what to put on the failures? How did you figure out that power? Didn't you just subtract? Like when it was 40 and 28, where'd 12 come
1
from?
minus p.
40 minus 28, so it'll be n minus x. So the formula makes things look worse. Doesn't that look worse than anything we did? Show, okay, not that much worse, but worse. The n minus x is the only way math can say the rest. Math can't speak English. So how does it say the rest? Total minus what you did already, right? N minus x. Maybe? So that's the formula. But just remember, we didn't even have a formula. We did a lot of stuff already. So what's less than 2? Well, first off, what's n? What's p? What's q?
N is 14.
N is 14.
Is
Yeah, just tell you.
0.13.
0.06.
So what's q?
0.0.
0.907, 11. Okay, what's less than 2 mean?
0 or 1.
Jeff, you have to put something before you put the word or. Do I have to do 1 minus? No, because we're not doing the opposite, are we? So don't suddenly think, oh yeah, every problem is going to be 1 minus. No, I get some people that do that. No, only when you need to use it. 0 or 1 is less than 2. So now you just got to do the probability of 0 plus the probability of 1. Now go ahead. See if you can do the probability of 0, and I'll catch up.
Did I do this?
No, stop, I'm sorry. Let everybody set it up. Don't say anything. I do appreciate the eagerness, I do. So help me out. Give me, how does this get set up? 14,
C1,
choose 0,
times 0.093.
0.093,
0 power, times 0.907 to the 14th power.
Good. So real quick. In English, this would be, I got 14 people, I want to choose none of them to succeed. So I have no successes. It's a little repetitive, which is nice. 14 people, choose nobody to succeed, no successes, the rest are failures. It's kind of nice that you can sort of read it like a sentence. Right? And some of you guys are like, good for you, man. I don't know what to tell you. All right. And so I'm going to plug that in the calculator, and then I'm going to add to it the probability of 1. You can actually put this whole damn thing in the calculator at once. So what would the formula for 1 be? 1, 4.93 to the first power, 0.907 to the 13th. Good. 13 plus 1 is 14. You can always double check. I get people that kind of get stuck on a number sort of stays the same or something, but just every time you use it, it's got to add up to be the same number of people you got. You can't create people. Not that quickly anyway, so. Okay. So you can throw that whole damn thing in your calculator exactly like that, believe it or not. Oh, it's fine. Oh, I'm gonna do something different. I'll explain why I can do it. Tell me if you get what I got.
This is for probability of 0?
That's the whole damn thing.
Probability is less than.
Oh.
Whole damn thing. So real quick, how many ways, if I have 14 people, how many ways is there for me to choose none of them? One way. You guys with me? I choose none of you. There, it's done. There's not more than one way to do it. And I don't mean to go, I choose none of you, or I don't want any of you. No, it's just, there's only one way to not choose anybody, and that's just don't choose anybody. What is anything to the 0 power? 1. So the only thing in this whole thing that's not 1 is this guy. Do you have to remember that? No, just put the whole damn thing in there. I'm just saying your calculator will know they're 1. They'll do it for you. Did anybody else get that same number? Anybody else? There, you guys got it? Yeah? Okay. So either we're all wrong or we're all okay. All right. Anybody not able to get that number?
Good question.
Yes.
So how would you know, like, just say on like the quiz that we would know to do 0.093 to the 0 power instead of 0.093 to the 14 power?
Because this is success. And you don't want any successes. This is always the number of successes you want. So it's always going to be the power of the first two. That's the successes, yeah. Okay. So everybody okay? Either you got the right answer or you're just accepting for some reason that you can't get it. Is that what's going on? Okay. All right, so let me ask you this. I made the probability pretty low, didn't I? I did that on purpose because I wanted the probability 0 and 1 to be big. If the probability is so damn low, isn't the probability that nobody succeeds pretty high? Does that make sense? Yeah. The probability is really low that anybody could jump over a certain thing. Then what's the probability that nobody makes it pretty high? You guys, does that make sense? So I wanted to make sure we weren't getting some crazy ass answers like 0.00000000035 or something crazy. I guess sort of. So real quick, let me say this a different way. 9.3% of the time, somebody will succeed. Does that make sense? How many people do I expect to succeed then out of 14? How many people do I expect to succeed given this situation out of 14? What percentage do I expect to succeed out of any group of people? Say again, sorry. Where'd that come from?
Oh, no. 9%.
9.3%, correct? 9.3% will succeed. Of 14. I've got 14 people, correct? So I do 0.093 times 14. What is that? 1.3 something? Blah, blah, blah. Okay. That would be the average. So let's do a better example. These numbers are a little bit gross. Does anyone know who Shaquille O'Neal is? Okay. He used to actually play basketball instead of just talk about it. Now when he played, he couldn't really make a free throw to save his life, so I like to use him as an example. I'm a Celtics fan, by the way. And quick story, back in 2008, they won the finals, and I printed out a final exam. It was all in green, and it had the Celtics logo at the top. And this one Lakers fan in my class, he said, I can't write. I'm like, too bad, you're going to fail. And, so I was a little evil, but too bad. Passed job, very evil. So let's say that he makes 30% of his free throws. Let's be nice. And he takes 20 free throws. These numbers are nice, right? How many would you expect him to make? See, that's easy, right? It's the same thing we just did, just a little bit easier numbers. He makes 30% of his free throws. So any group of free throws he makes, I'm going to expect him to make 30% of them. Could he make more or less?
Yeah.
Yes, but on average, it's going to average out. He could make all of them, but then over time, it's going to average back out. You guys with me? So I would expect him to make 0.3 times 20, which is 6. So what's the formula for expected value? Well, what's the other name for expected value? Mean. So the mean, what's 20? in variable speed. N, and what of course is 30%, 0.3, P. Probability of success, right, P. Do you understand what just happened? That is the best formula for mean we've had yet. I just have to know two numbers and multiply them, and I know the mean. Do you guys see that? Remember sum of x, p of x? So you had to make a bunch of x, p of x's, and then you had to add them up, and blah, blah, blah. Now watch this, even better. Standard deviation is always worse, always. But here's what the standard deviation is. Square root of NPQ. No sums to do. That is a little out of most of our mathematical ability to explain why the formula is that. But that's what the formula is. Right? So everybody sort of, yeah.
NPQ.
Square root of NPQ, yeah, my Q's get weird.
Or you get Q then, like what will Q be?
Oh, well, what would Q be? If P is 0.3, what's Q? 0.7. Yeah, same as always. P and Q have to add up to be 1, always. Now, let me give you this. I know you're going to be shocked, but I have a handout. On this handout, I tried to kind of partially set things up for you. I'm hoping it doesn't actually end up confusing things. Alright guys, so I'm not going to force you to do this, but it'd be great if you work together with somebody. Alright, let's see. Alright guys, so your N is what?
44.
Yeah, 44 total San Diegans. P is?
0.152.
Yeah, get in the practice, get in the habit that these are probabilities. They should be between 0 and 1, right? So that makes Q. I kind of gave it away here, but oh well. Alright, so again, this is just to show you the buttons you would push. So here, I want exactly 7. So I've got 44, I want to choose 7 to be successes. So that means I have 7 successes. How many failures?
37.
37 failures. Cool. And I think you get
16.
Is that cool?
I did some.
And again, you can make that 16.11 if you want to. Either way. This guy, probably that none of them smoke. So it's exactly, I could put whatever number I want to there, except for anything above 44, of course, but. So now I got 44 people, I want to choose how many successes?
0.
None. So I got no successes, so that means I got 44 failures. Personally, I would call them successes, but that's all right. So this one is where you got the weird thing. You get something like 7.06 blah, 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 E negative 4, right? So you move the decimal 4 places back. Once, and then 1, 2, 3. So the shortcut is, whatever this is, if it's negative, I'm going to have 1 less 0 in front of the number. So if it was E negative 6, I would have 5 zeros and then the 7. Does that make sense? It's a little shortcut, yes. No. Okay. Because I need to see that you know what that means. If you just leave it, I don't know if that means you don't know what it means. You're like, well, technically he's right. No, I need to see you know what it means. Some of you guys were doing work here, but we already did most of the work we need here, right? Is everybody cool with this? At least 1 is the opposite of none. So 1 minus none, we already did the probability of none. So that would be 9993. I love it. Somebody this morning was really freaked out about that. They're like, that can't be right, that can't be right. It's a really low chance that one person smokes, correct? 15.2%. It's a pretty low chance. Are you with me? Could be lower, I understand, but that's pretty low by itself. But if I pick 44 people, I should feel guaranteed at least one of them's going to smoke. Does that make sense?
Yeah.
It should be really unlikely that none of them smoke. Does that make sense? Because I have 44 chances to find somebody who smokes. Is that cool? So it makes sense that that's so high. Okay, maybe. And then these guys are just really quick little plug and chug. N is still 44. P is still 0.152. By the way, real quick. This is a fact that we're given. We're just going as if this is just the gospel truth, right? I don't care what question I ask. I cannot somehow change this, correct?
Correct.
That would be a neat power if by asking a question I could suddenly alter reality to be, now suddenly more people smoke. Stop asking questions, Jeff. All right. You guys sort of with me? So I always get people that change this number based on the question I ask, and I'm like, no, we can't do that. We don't have the right infinity stone. Oh shit, I went there. All right. So what is this? If you do this multiplication? 6.688. 688? Okay. So if I pick out a random group of 44 San Diegans, I expect around 7 to smoke. Okay. And the standard deviation, gotta throw all that stuff in there, and you get who to what?
2.3815.
2.3815. 15. Okay, look, that's, if you want to, sure. Okay.
I want to.
Now you could round up to 3 places if you want. I don't know what came after that, but okay. I think I couldn't remember, but I'm pretty sure we talked about what unusual, the idea of it being within 2 steps.
Yeah.
Because it comes from kind of like normal curve. 95% would be within 2 steps. Even if it wasn't normal, at least 75% of the data would be within 2 steps, no matter what the distribution looked like, which is a neat theorem of its own. Say again? Sorry? So if I put the mean in the middle, where do I end up if I go up 2 steps?
11.
Who is it?
11.45.
11.45?
Yeah.
And if we go down 2 steps, 1.926? Is that what you guys said?
Yeah.
All right.
Yeah.
So I would expect, out of 44 people, I would expect to get somewhere in here.
Right.
So they're asking me, is 15 unusual?
Yes.
Yes, because it's way outside of what I expect. So 15 would be unusually high. Right? Think about somebody who's been unusually high. But so this could mean if I'm in a certain part of town, this could mean something about just that part of town people happen to smoke more or something. Does that make sense?
Yeah.
It could indicate, so though, let me say a name to you guys. Aaron Brockovich.
Oh, yeah.
Is that name just anybody aware of that name? It's a nice name, I like that. Aaron would appreciate that. Anybody know Aaron Brockovich? Me and Charlton is the only one. There was a movie a while back with Julia Roberts about the water. So this is a real story. So she found out that PG&E was polluting the water, and that was harming families that were drinking and bathing in this water, and it was, and yes, I'm aware of the way I say water, by the way. Some of my friends really give me shit about it, so I water. I started just doing that. So the water was really causing a lot of trouble. And so you have an expected number of cancer cases in any given group of people. So you can do something like this. Is it unusually high number of cancer cases? And then we can go in and we can check the water, we can check the air, we can check the food, we can check the ground, we can check whatever. Does that sort of make sense? Now, just because it's unusually high doesn't mean that something necessarily is wrong. Because is that a 0% chance that we get 15? No, it's just a low chance. Do you guys see what I'm saying?
Yeah.
So it doesn't mean something's wrong, but it is something to check. correlation is not causation is sort of related to that. So this is sort of like I'm in the yellow. The further out I get, the more I get into the red. You guys with me? Sort of like the nuclear power plant example I was talking about before?
Yeah.
Okay. Any questions from this? You guys are so hopeful. We got more to do. All right. So that finishes up chapter 4. So let's talk a little bit about chapter 5. Oh yeah. Let's see, so we're just going to do a little bit out of 5, then we're going to call it a day. I didn't make it too much further in my first class, so we're not going to do too much. Yes.
I keep doing this for
What's going on, this poor little dude? So what? Sorry, what's up?
I have this set up just so we had it right on the board. Is that right?
But you left out this part. Yeah, that's the really important part. All right, guys. So even if none of you have ever actually played a game of darts, has anybody ever played, or even just thrown a dart towards a dartboard? Is anybody like a professional darts player or played? Yeah, I like. That's hilarious. I have had somebody in the past that was actually. There's this cool, by the way, there's this cool video I found where this guy constructed this thing using a lot of cameras. If you throw a dart, it'll move the dartboard and it'll be a bullseye every time. And I show that to my, well, I used to show that to my algebra class when we were allowed to teach algebra, but that's a whole other story. Because they use parabolic motion to determine the up and down of where the thing should be, and they use linear motion to determine where it should be this way, based on the motion of it moving. Anyway, I just like to show that. It has nothing to do with the day, I'm very sorry, but dart just made me think about that. If you wanted to impress a friend with your ability at darts, what would you do? What would be the most obvious thing you could do to impress somebody? I'm not going to get the right number of things, I don't care. Yeah, just hit the bullseye more than once. So why would that be impressive? Why would that be more impressive than getting the dart here, for example? It's a bigger area, right? So we all inherently understand that the bullseye is more impressive because it presents a smaller area to hit. So if I can get in there a decent percentage of the time, that is evidence that I am good, because I am making the dart go where I want to. If I am not that good, I might say, okay, I'm just going to get it in this part over and over and over. That's not as impressive, correct?
Right.
Because the larger the area there is, the higher the chance I just randomly get it there. Does that make sense? If I get that bullseye 5 out of 5 times, there is a chance that I just got completely lucky and I've never held a dart before in my life. Does everybody agree with me? There's a chance, but it's damn tiny. You guys agree with that? Okay, maybe. Do you see how the area, if I have a visual of a probability situation, everybody agree this is a total probability situation. If I threw a bunch of darts at the dartboard and only counted the ones that hit the dartboard, not the wall, not the people walking by. Ouch! All right, go on. If I only counted the ones that hit the dartboard, more of them would land where there was a larger area. Does that make sense? Of course, right? So randomly, if I just randomly threw it there, a small percentage would hit here. In fact, if I knew the area of the bullseye was 10% of the area of the whole thing, which I don't know if that's true. I always forget to look that up, but oh, too bad for me. Let's pretend like that's true. What percentage of the darts I throw should land there? 10% of the darts I throw should land there. Does that make, let that just tell me if that makes sense. If one of these triangular kind of regions, these weird little trapezoidal curvy regions, if that represented, I don't know, what do you got, Jeff? 30% of that doesn't make any sense. 10% doesn't make sense. Who cares? If that's 20% of the area, then there would be 20% of the darts would hit that triangle, just randomly. You guys with me? So if I did not know how to play darts and I threw 10 darts, I would expect maybe one of them to hit here. Does that make sense? 10% of 10, right? What does this have to do with anything? Well, we're getting into chapter 5. And in chapter 5, we introduce the idea that if I can give a visual representation of the probability distribution I'm working with, holy shit. We already have an example of that. Could everybody here draw a normal distribution?
Yeah.
Do it in the air for me. What's a normal curve look like? I like it. Sweet. And there's very few things that are perfectly normally distributed unless you do certain things, which we will do later this semester, and all of a sudden a lot will be. But normal curves we know a lot of shit about. What if I had a curve? Let's see if you guys are cool with this. Sure, we'll go with that example. Let's say that it takes Jeff anywhere from 1 minute to 9 minutes to find his keys. Right? And we'll further say that it's uniformly distributed. The probabilities are uniformly distributed. What do you guys think that means? What's uniform? When I say uniform, what do you guys think of?
The same.
Same. Some of you guys think about things people wear, right? And again, that's another idea of same. If there's a uniform for a cop, they all freaking look the same, right? Say, oh, that's what uniform means. It's the same. So uniform distribution means nothing is more or less likely than anything else. So it's just a flat distribution. It's not like a normal curve where the middle is a higher chance. So this is going to have the shape like this. 1 to 9. So the probability takes me 4 minutes is exactly the same probability as the probability takes me 3 minutes and whatever. So here's what's really cool about this. If I can make that entire area 1, which is the visual analog to adding up all the probabilities and getting 1. Are you guys all with me? This is sort of like a histogram where the height, I have a bunch of little bars. In fact, how many little bars do I have? How many times are between 1 minute and 9 minutes? No. I love it, you guys. What about 2.536924444397 minutes? Is that in there?
Yeah.
Okay, now how many minutes are between 1 minute and 9 minutes? Infinite, 11. So I have an infinite number of little rectangles, and they all go up to the same height. Are you guys sort of with me? All right. That sounds a little insane. You're like, what's the work look like for this shit? Well, here's the beauty of it. Just like the dartboard, just like the bullseye area is equal to the probability of getting that bullseye. If I ask you a probability question, what's probably that it takes me between 3 and 7 minutes, let's say, right? Well, one thing I haven't done yet is, what am I missing for us to tell what the area of this is? How wide is it? Now come at me. 8. Okay. What am I missing to figure out the area? The height. What's the height gotta be if I want, what did I want the area to be? 1. I want the area to always be 1. So that's 100%, correct? So what would the height have to be in order to make the area 1? 1/8, the reciprocal of 8, correct? Whatever the width is, the height's gonna be 1 over that. Isn't the area now 1/8 times 8, 1?
Yeah.
So has everybody drawn this picture in your notes?
Yes.
Now I can draw the question. 3, 7. What's the area of that rectangle is the answer. Just like the area of a bullseye would be the answer of how many randomly thrown darts would end up in the bullseye. Same idea. What is the area of the rectangle I just shaded in? How wide is it? 4. And how tall is it? 1/8. So that's going to be 4 times 1/8. 50% chance, right? You guys semi with me? Uniform probabilities kick so much ass because they're just big rectangles. So it's our first little kind of approach towards continuous distributions. This is cool. This is a continuous distribution now, right? It's like we just said, there's an infinite number of things. It's continuous. So what's really cool is any continuous, so you see the problem with normal curves? If I want to know the probability between this and this, do I have a formula for the area of melted side rectangle? Do you guys remember that from geometry? Do you see how that's like a trapezoid, maybe that where one side melted or something? Do you guys see that?
Yeah.
I don't have melted trapezoid area formula. If you do, show it to me. That would be so sweet. So we're going to have to figure something else out when we get here, but the idea remains the same. The answer to the question from here to here will be the area of that thing. We're going to have a nice, quick way to figure out the area. We're not going to do it geometrically because that would be really weird. Do you guys agree? That's not a standard shape. It's like a crayon you left out in the sun too long when you're a little kid, right? All right. Okay, so obviously that was a quick little, I just want to lay some groundwork for chapter 5. We'll get into that more fully next time. I think I'm okay with leaving a little early, if you guys are.
Those less than signs or signs?
Less than signs. Yeah. Yeah, I'm sorry.